In Chapter 12, we're going to be talking about solutions. Remember that if you have a solute, that would be the solid or the concentration. It could be in liquid form. And you add that to water or sterile saline. You have a solution that can be used either to inject or to wash aside. It's the same process as when you make hot chocolate, where you take the powdered chocolate and you mix it with milk. So you have the solute and the solvent, and then you have something delicious to drink. So the things that we want to talk about today is the process of mixing and diluting solutions, and then we want to remember the terms. The solute, again, is the substance to be dissolved or diluted. It can be solid or it can be in a liquid form. The solvent is the substance, the liquid, the saline solution, the water, distilled water, that dissolves another substance. And then solution is the result or the mixture. We have to be careful when we're reconstituting injectable drugs. We have to read and follow the label or package insert carefully. We have to check the drug, and we have to check the drug and dilute dates. Because you have to discard any solution that has expired and loses its strength. We want to determine about the type and amount of dilute to be used, determine the volume in milliliters of the dilute to be used for the route as ordered, and reconstitute the drug and not the resulting supply dosage on the vial. Now, parenteral solution from a solid solute. So we are using Zithromax. And it says to use 4 8/10 milliliters of sterile saline, or sterile water, excuse me. So you withdraw the 4 8/10 and put into the powder. And what you have is 5 milliliters of reconstituted solution of Zithromax, 100 milligrams per milliliter. So this is the strength per amount. Now the label for reconstitution of the Zithromax might look like this: 1 to 10 to XX 0800 reconstituted as 10 or 100 milligrams per milliliter. This is the date. You have to always put the date that the reconstitution was done and the date that it expires. You also put the strength after it's been reconstituted. It's 100 milligrams per milliliter is the dosage strength you've mixed up. And you want to keep it refrigerated, and then your initials. So, if the doctor orders Kefsol 220 milligrams IM, means in the muscle, every 6 hours. So this is what the doctor has ordered. This is what is desired. If you inject 2 milliliters of air into the sterile water dilute, then you will be able to withdraw 2 milliliters of solution. I shouldn't use the word solution, liquid. So you inject 2 milliliters of air, then you withdraw 2 milliliters of water. You put the 2 milliliters of water into the powdered Kefsol. And then you draw out 1 milliliter for the dosage, 225 milligrams per milliliter. So here's the rule. When reconstituting multiple dose injectable medicines, verify the length of the drug potency. So if you mix it today, can you still use it in a week? You want to label the reconstituted multiple dose medication with the date and time of preparation. So not just the date, but the time. So if we go back to this label, the 800 means the 8 a.m. Remember, we're doing military time. So on January 10th of some year at 8 a.m., you mixed 100 milligrams per milliliter strength, and it will expire on January 17th at 8 a.m. So you have the date and the time of the preparation, the supply dosage prepared, the length of the potency, so the day that it will expire and the time that it expires, the storage directions, and then your initials. So that's what you have to put on all the medicines that you reconstitute. Now the math tip, when multiple directions for diluting are given, the smaller the amount of dilute added, the greater or stronger the resulting solution concentration will be. So that just makes sense. The less milk you put into the cocoa, the stronger the cocoa will be. Alright, if you have 500 milligram vial of powdered solumedrol for IM or IV injection, so in the muscle or by IV, this medication can be given. You reconstitute with 8 milliliters of bacteriostatic water for injection with benzyl alcohol. Methprednisolone sodium succinate equivalent to 500 milligrams methprednisolone 62 and 5/10 milligrams per milliliter. So what do we know? First, to fill the order, how much and what type of dilute must you add? So the directions state to add 8 milliliters of bacteriostatic water for injection with benzyl alcohol. Second, what is the supply dosage of reconstituted solumedrol? When adding 8/10 milliliters of dilute, the supply dosage is 62 and 5/10 milligrams per milliliter. You get this information from the label. Third, what is the resulting total volume of this reconstituted solution? So the total volume is 8 milliliters. So you know this because 62 and 5/10 milligrams per milliliter times 8 milliliters. See, this per milliliter means milliliters would be in the denominator. So the milliliters would cancel out, and it would leave you with 62 and 5/10 milligrams times 8. And so the amount you end up with will be in milligrams. Finally, how many full doses of solumedrol are available in this vial? So the vial contains 500 milligrams and the orders for 200 milligrams. So this goes back over dosage desired, or what's desired, over what you have. So if I am looking for how many doses I could get, 200 will go into 500 2 full times. So you would be able to give 2 full doses out of that vial, and then you would have 100 milligrams left over. Now you have a vial of 500 milligrams of solumedrol. We added 8 milliliters of dilute. So the final yield is 62 and 5/10 milligrams per milliliter. That's your supply dosage. And now you calculate one dose. So step one, we want to convert. So we need to make sure that our units of measure match up. So in this case, no conversion is necessary because our order is given to us in milligrams by IV every 6 hours. And our supply is in milligrams per milliliter. So you think, am I going to give more than 1 milliliter? Am I going to give less than 1 milliliter? Am I going to give 3 times 1 milliliter? So what would be a reasonable amount? If they ask for 62, or this is our supply, and we need 200. The doctor has ordered 200 milligrams. We've got 62 and 5/10 milligrams. Do we have to give more than one or less than one? So we have to think about what is reasonable. And so we know that we're going to be giving more than one. Then we do the calculation. The desired is 200 milligrams over what we have, and its quantity is 1 milliliter. Now, injections or IV are given by milliliters. So we have to set this up so that the milligrams cancel out. And after you do the math, you get 3 2/10 milliliters given intravenously every 6 hours. A fraction expresses the strength of a solution made from a liquid concentrate. So the numerator is the number of parts of solute, and the denominator is the number of parts of solution. So the difference between the denominator and the numerator is the number of parts of solvent. So if I want 1/3 strength, the 1 represents the concentrate. The 3 is the total parts of the solution. And when I take 3 minus 1, I get 2 parts solvent. 1 is the concentrate, 2 is the solvent. The 1 and 2 add together gives you the total solution. So to prepare solutions, we apply our same formula where we take the desired times the quantity of the desired solution, and that will be the amount of solute. So we want the desired strength times the quantity of the desired solution, and that will be the amount of the solute. So the quantity of the entire solution is the solvent equal to the solute. To prepare solutions, apply formulas to find the amount. The desired strength times the desired solution equals the amount of solute. The quantity of desired solution has the solute equal to the solvent. Now, let's look at an example. A physician orders a patient's wound irrigated with strength 2/3 hydrogen peroxide and normal saline solution every 4 hours while awake. Two-thirds hydrogen peroxide. I want 2 parts concentrate, 1 part water. Together they make 2/3 strength, or it's saline. It's 2 parts concentrate, 1 part saline, and that makes the 2/3 strength. So you have 60 milliliters per irrigation for 3 irrigations during your 12-hour shift. So if you have to use 60 milliliters per irrigation and you have to do 3, you're going to need 180 milliliters of the solution. So how much stock hydrogen peroxide and normal saline will you need to order from the pharmacy? So first of all, we see if we need to make any conversions. But if we look back, we can see that there are no conversions that we need to make. It's given to us in milliliters, and we know we have to have 180 milliliters, so nothing to convert. And then we need to think back about what we're going to need. We are looking at 2/3 strength hydrogen peroxide. So you have a 12-hour shift, so you're going to do this 3 times. You do this every 4 hours. So we think, I need 2 parts solute, and I need 1 part saline. Together, 2 plus 1 makes the denominator of 3, the total solution. For 180 milliliters of solute, you will need 2/3 of it as solute. So 2/3 of 180 is 120. And 1/3 of it will be solvent. So 1/3 of 180 would be 60. So the desired strength, which is 2/3, times the quantity, 180 milliliters, means I need 120 milliliters of solute.